I'm starting up the stream. Should be ready soon. Looks like the stream's going. Hi everyone, I'm TigerHawk3, and today we are going to continue the Python Deque implementation. Python already has a Deque in the standard library, and that's in collections, collections.deque, D-E-Q-U-E. And we're writing one ourselves because we are. So we've got a nice little slightly more than basic implementation. That's a lot of testing. I'm gonna remove some of that because I know it works. And then we're going to change a couple little things and then add some things. First, this iterator method. This is a magic method, also called a special method for Python, because it starts and ends with a double underscore. These methods in Python are generally ways to connect your class to Python syntax. Like, for example, the len special method, starting and ending with double underscore, connects to the built-in function len, and it lets your class return something that should be the length. And there's bool, which allows your class to be instances of your class to be evaluated in Boolean context. And there's add, which is what's called when you have one instance of your class plus another instance, and then it calls this add method. There's also sub, mul, etc. for all the other operators. If you have like a numeric class where those make more sense. Iter is called when you try to iterate over your class. If you do for item in my Deque, then you get this, and it yields a bunch of stuff. This thing right here is not necessary. If it's empty, return an empty iterator. It just won't yield anything. We don't actually need that. So, some operations in here involve iterating over a Deque and looking at the actual nodes. Like, for example, reversing might have some of that. It kind of won't, sort of, in a way. Anyway, I'll get to that. But what we're going to do in chat, the Adamorm says, for a total noob, what is the best place to start with Python? I would say the official Python tutorial. You go to python.org, look in the documentation, look at the tutorial. It is the only good tutorial for any programming language I have ever seen. All the other ones are bad and confusing and fragmented and weird. Python official tutorial is great. Covers things you need to know, tells you about little tips, things to watch out for. It is very excellent. So we're going to have a method that just iterates over the nodes in our Deque instead of yielding each element in our Deque. So I'm going to call this one underscore iter. This is not special. It's just slightly hidden, perhaps, when you look into all the attributes of an instance of this class. It won't show it necessarily, but you can access it if you want. Like, you can go, my Deque dot underscore iter equals 5, and then it'll be 5 instead. It's not it doesn't have any special meaning other than it is hidden sometimes when you look at the object's attributes. And you're welcome, the Adamorm. If I started with a double underscore, then that would be introducing name mangling, which means the name of this method would be mangled. You would need to also start it with the name of the class, with some underscores, etc. This is just things to prevent people from accessing these things too easily. If you have something really internal to your class, but you can always get to it if you really want to. And part of how Python works is the phrase, we're all consenting adults here. If you want to go in and change something, you can do that. Maybe it'll break stuff, but if you didn't want to break stuff, you shouldn't have messed with it. It's the idea. And we are going to actually do this. Now watch this. Now it's just the nodes. And now I can do for item in iter. Yield item dot element. There. Very good. And now this takes care of iterating forwards over the deck, but how about backwards? There's actually kind of the equivalent for this, only backwards, and that magic method, which is called by the built-in function reversed, is _reversed. And we're going to do something similar here. What is this? How far does this go? Iter and iter. Reverse iterator. That's going to do current equals self dot last. Current yield current, and current equals current dot prior. Okay. And then reverse just has to do for item in reverse iter. You have to call that to actually make a generator object, otherwise it's just a method. And this needs self, or it'll have no idea what I'm talking about. Yield item not element. There. And now we have our 1_iter and 1_rev iter to iterate over nodes. The Atomorm asks what I'm working on at the moment. This is a Deque, a double-ended queue. And there's actually a previous video about this, part 1. I made a simple version offline before starting, and then part 1 is adding a bunch of stuff, and part 2 is this. So if you want, you can go back and watch. All my videos are archived, and you can catch up in the series. So when you call the built-in function reversed, it calls the instance's _reversed method, and this is an iterator. As you can see, it doesn't actually change the order of anything. The object is still the same. So, and this is this is basically iter, only backwards. And reversed, etc. There is also a collections.deque and probably lists, etc. have a built-in method called reverse, which reverses in place. I don't think it has a sort. I really hope not, because that sounds annoying to implement. Yeah, there's no sort on a Deque. Good. And yes, it is cool. Quite cool. It's very short in Python. Last time I was writing some methods for stuff, like this for example, and then I would be like, I'm done. I would spend a couple of minutes explaining what it was doing, and then I would write it, and that would be that. So, we are going to write a reverse method. Which reverses this iterable in place and returns none. One way to do this would be to remove each item, to pop from the right and then append it to a different deck and then pop them back, just, you know, backwards. That would be 2 pop, append. That would be 2 pops and 2 appends for each item. That'd be pretty bad. So I was thinking earlier today, do I really have to do that? Because remember the ordering basically of this object is stored in the nodes. We have the first one that points, we have first and last, that point to the first and last, and then each node has a prior and a next, and that's all there is. So one thing you can do, one way to do this, which I actually tried implementing today, is this. And then for item in self, self dot underscore iter. So we need this. Yes. This is giving us each node, not each element in the node. So for item in self dot iter, item dot prior, item dot next equals item dot next, item dot prior, and that would be that. That's done. That's it. So what this does, this is a very common Python syntax called multiple assignment. So we have the last element and the first element, and we're going to put each of those into the first and last. It's basically it's like saying temp equals self dot first, self dot first equals self dot last equals temp. It's a swap, and this allows us to do it in place, and we don't need a temporary thing because it takes care of that. So instead of having the Gatamorm asks, can I be a pain and derail you for a moment to ask what the binary conversion.py tab is? That's this, yeah. I'm currently taking a class for computer architecture with bits and MIPS, and I don't mean million instructions per second, although that's part of it, oddly. I mean the MIPS architecture, which is not in use anymore, but we're learning it because we are learning it. And this is, for now, all it has is a decimal to binary function. So you give it a decimal number, like a regular number, like 3 or 12 or something, and it gives you the binary 2's complement value. I actually have, hang on, let's see if does will this work? Properties. Did it switch? No. Oh, now I have to choose which command.exe. There we go. All right. Does this. So true and true. The binary value of 0.5 is 0.5, and that's 1, meaning 1 over 2 to the 0. and this is 1 over 2 to the 0 plus 1 over 2 to the 1, etc. and so forth. Just keeps on adding, you know, negative powers of 2. Negative 3.5 is, here's a negative number in 2's complement. The way to invert this is to flip all the bits and then add 1. So we would have a bunch of zeros and then 1 0, and then we add 1, and that's 1 1, and 11 in binary is 3 in decimal, and then here's a 0.5, and here is 0.75, etc. So yeah, that's what it does. And you can have it cut off the leading zeros if you want, and cut off trailing zeros if you want. Anyway, that's what that is. Where's the thingy? Here we are. Dimitrios Desmos says, "Hi Tigerhawk." Hello. The Adamorm asks, "What's the use for this? What's it for?" Sometimes I have homework for this class, and I don't want to be, well, there's a binary thing already, a bin function in Python, but I wanted to make this 2's complement thing primarily for fun. Is it still that one? I don't want that one. There we go. Now it's right. So yeah, I felt like it, basically. So we switch the first and last, and back to our deck. We have the first, and then a bunch of next, 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 and the last with prior, prior, prior links. So we're going to say, okay, first thing we do, this is the first one, and this is the last one. So we say for item in self._iter, which says we're going to start with the first, and now the first is this one at the end, right? So we have this one at the end, and maybe there is, and so we're going to yield that. And then after that, we say current equals current.next. Did I do something wrong? I don't think so. Yes, so we start with the first one, which is the old last one, because we've called this first now. We switch those. This is first. And then we yield this current one back to the caller. And then the caller does this, swaps the prior and next. So instead of next being this way, which ordinarily there would be nothing, it says now they're switched and next is this way. And then we go to the next one, and then we switch the prior and next, go to the next one, switch the prior and next, and now next go this way. So that just switches all the links. And that's all that is. Can you turn your mic up? I don't really have such a control. I can move it a little closer to my face, maybe. Hopefully that doesn't get, hopefully that helps without making, introducing too much noise. Because this headset does not have a windscreen of any kind. Let's see. So I tried this earlier today. It is very, very slow compared to the built-in deck anyway, which may or may not be implemented in C. I'm not really sure. Actually, I think I can. Can I do that? No. No, I think that's written in C. So, it's very, very fast. And he says that works, thanks, cool. The standard library deck is very fast with its reverse. But the one I wrote here, one sec. one I wrote here is not very fast. For very small decks of like one item, for example, mine was a few times slower, and the difference only increased with the larger N. For like 100 elements, I think it was like 50 or 60 times slower, and then 1,000 or 10,000 elements, it was 300 or 400 times slower. So, and that's related to just how much overhead is there in it. That's not related to how many elements you have. But yeah, it was pretty slow. So then I had an idea. What if, instead of turning it around, we just look at it backwards? If we just look at it backwards. So here's what we had. Here's what we will do instead. That's what we are doing instead. So that will basically swap these two methods, the iter and the rev iter. So when we say this is how we go forward, okay, when we reverse it, we will say this is actually not forward, this is backward. We'll just, so when we call iter, instead of doing this, it will do that, which is backwards. Now there's some other stuff we have to switch as well, and those would be the pop and append stuff. So now we have to think. We have our items left to right in a forwardly manner, and then we switch it around. So now when we want to append, we actually want to append on the left. And when we extend, doing a bunch of appends, that's actually an extend left. So we do append left. Now let me look at the extend left. Yeah, that's the only difference they have. Clear, copy, count. Okay. I will switch pop and pop left, append and append left. That's somewhere here, right? Append and pop and pop left, append and append left, and extend left. I'll have to switch all of those. It will never know that it has been switched. Of course, if you perhaps access... Is there any way to mess this up? I don't think so, because I'm literally just switching them around. I don't know. But anyway, reverse. Where's reverse? Here's reverse. Self.pop left, self.pop. Demetrios Desmos says, totally awesome coder, best on the web. Neat. Thank you. And yeah, Norm has subscribed and is going to binge watch my videos. Cool. Thank you. I'm getting compliments in chat today. That's cool. Pop and pop left. And append. Okay, and self.extend left, equals self.extend left, self.extend. Now the standard library collections.deque is not O of 1 on reverse. it is an O of n, but it's pretty quick as these things go. It's pretty much as fast as reversing a list. But this should be O of 1. And I actually tested it earlier today in a class, actually, because it was boring. Anyway, there were actually some mildly interesting parts in class today. So I was like, oh, okay. For months. I don't know. But, and this is not connected to the length of the deck. It just says, now it's backwards. So you just look at it from the other end without having to turn it around. Isn't that cool? Now it's like a gun at a shooting range. And if you want to look at a different part, you don't go like this. Move around it. And then it keeps pointed in the same direction. This deck will always point in the same direction. You're just looking at it backwards. Hopefully that works. We will need to keep in mind that we did this if we ever have more stuff that that relies on directionality, like Append and Pop did and stuff. Anything that refers basically to a node's next and prior, or the deck's first and last. Next and prior, really, because first and last are already switched, so that should work fine. But it's the next and prior that aren't switched. So if we're looking at next for everything, when we want to look at prior, we'll have to, ideally, both those methods, there will be a pair of methods, and we can just switch them. I hope. Yeah. And for things that don't have a doppelganger method, like Append and Append left, hopefully it won't matter. Although it might. Indexing, slicing, I'm not sure. But hopefully that'll work without exploding. You don't want your code to explode, generally. Unless you plan on that. If you're making a game, there's an explosion. But then you're just animating an explosion. It's not actually your code that explodes. A virus explodes. I actually I think bothered my teacher a couple of weeks ago. He was explaining to us that quality is good and delivering software on time is good. And how do we define software? This is for a third quarter Java class on data structures and algorithms. Stacks, queues, binary, search trees, and so on and so forth. And he's spending the first lecture on software quality is good. I'm not even kidding. But one of the things he said was that any software that's supposed to be useful needs to display some kind of result. If it just works and works in a loop or something with no result shown to the user, then that's not useful. And I said, viruses. And it's like, it's basically those don't count. Let's not write viruses. I'm like, I don't know. But viruses are useful to someone. You don't always want output. But anyway, the Animorm asks, is there any real instance where you would use another language instead of Python, or can you do pretty much everything inside of Python? Definitely yes, and definitely no. You can't make a modern AAA high-end graphical title with Python, because it's too slow. Note that I say modern and high-end, and I don't mean modern right now, I mean modern whenever right now is when you're thinking of it. Now should be defined when you call the function instead of on defining the function. Because modern game development means displaying the best graphics possible generally, whatever works at the time. So I mean, nowadays it's really easy to make, say, Tetris Python, which I have done. There's like 15 parts or something of a stream. You can watch it on my channel. I think if you Google Python Tetris, one of the main videos that comes up is mine. That's cool. But Tetris is not a modern game. Way back in the day, yeah, it was, took some power from the Game Boy. But today, always, modern games have gotten a lot fancier. So the way to get the best graphics at a constant frame rate of whatever you want, like 60 FPS is generally considered the standard. You have to use the fastest possible language, or a toolkit that is written backend in the fastest possible language, which is generally C. A lot of C libraries, maybe C++. So Python is not suitable if you want your program to run as fast as possible. Yes. So what would you use for that? Would C++ be better? Yeah, C and C++. You could write it in assembly language. That's what it used to be when you wanted your program to run really well, like 20 years ago. Like 40-ish years ago, you would write it in assembler, or 50 years, I don't know, 70s, 80s, maybe 90s, I don't know. If you wanted it to run really fast, you would hand tune some assembly language code, make it real nice, because the C compiler is pretty good, but maybe it wasn't perfect, and there's some little optimization you could do if you're really good with it. That is not the case anymore. For anything remotely complex, it's going to be too big to do by hand in assembly. It's just not realistic. And compilers have gotten better too. So, not very common anymore. And when would I use another language instead of Python? Instead of when would someone else do it? What I would is AutoHotkey. Because AutoHotkey has really easy access to Windows internals, like moving the mouse, etc., which is just not a realistic thing to do in Python. It would be really annoying. Of course, if AutoHotkey had a module for Python that you just import AHK, and I have a video about that where I play pretend. I say I would import AHK and then a whole bunch of AHK.mousemove. It was really pretty. And yes, assembly is tedious. That is very accurate. Do you know what the command is to print a string? For awful. And AutoHotkey, I don't like the language very much because it has a lot of old style things and traditional syntax and one indexing. But it is very useful when you want to do something for which it is intended. And when I want someone to actually run a program that I wrote, I use JavaScript, because there are a lot of people who don't have a Python interpreter installed on their machine, but there are many, many people who have a JavaScript interpreter on their machine, or an ECMA script interpreter, and that would be their web browser. Chrome, Firefox, Edge, etc. That runs JavaScript. So you just write it in JavaScript, and that's it. You put it on your website, and they go to the page, and it runs. So that's always cool. ASMR by Matthew says, "Good morning. There's a lot of beard versus microphone noise today." I put it maybe a little too close to my face. I don't know. Still working on this stuff. Best I can do. It's a new headset. Got it like a few weeks ago, but I don't want to do a lot of breathing into it. So I had it kind of out of the way. First video I had it right here. Maybe if I put it out here. I don't really know. I want it to catch my voice, but not my breathing. And it doesn't have a open screen, so I don't know. we're figuring that out as we go. Hopefully this is an improvement. I don't know if you can hear the noise of the cable rustling around. I don't think so. The language. I have to go. Okay, I will. Adam Orm is saying he has to go. Not I. Good to have you here, and I'll see you on another video, perhaps. But we will be continuing with Deque now. I don't know how we got here to whatever we were. What were we talking about? I don't know. But generally speaking, we are creating a Deque. And I came up with a really sneaky way to reverse it in place. It doesn't actually reverse anything. It just has us look at it backwards. I'm pretty pleased with that. So, what do we do now? Now, of course, we add things that rely on whether we're looking at it backwards. Insert, remove, and rotate. Okay. Okay. In Python, you cannot have a statement, or you must have a statement following a following something like a function definition or a for or while loop, and so you have to add, if nothing else, the null statement, which is a no operation, which in Python is pass. I'm going to test the nonsense that I did. I'm not going to test these things. I'm going to test some of these things. Okay. Let's make this a smaller, like 10. That's a better idea. I'm not testing performance right now. A pop left, a pop, an append. A few of these should be good. Pop, etc. I don't know. We've already done that a couple times. I'm done with that. I am so over all of those. Those tests were so yesterday, last week, whatever. D.last, I tested this. I don't care. D.extend. And this does take an iterable, okay. Extend left. Make a copy. Let's actually do this as well. Now we have a list inside the list, so now we have a mutable object over here. Actually, do we test that now? Or can we test that later? I think it already works with deep copy. I was reading the collections.deque API, and it said that it supports copy.deepcopy. Python has a module copy with a method or a function called deepcopy, and it makes a deep copy. If you just use the regular copy.copy or a slice or something, then you end up with another iterable that you have, and each item is a reference to the old one. So if you have a list of integers that you copy, and you want to say my new list bracket 0 equals something else, then you're just assigning a new one. But if you have, if my new list 0 is a list, and you do my new list 0 dot append, my new list 0 is still the same reference in both, and so you append and it will append to both. It's the difference between references and values. Some people say Python is passed by reference, others say it's passed by value of reference, but basically the idea is if your object is mutable, meaning you can modify it, then using the equals operator for assignment might not do what you think it does. So I tested it, and it, did a deep copy. Fine, didn't have an error, and it copied the thing with the different references. It was fine. It's fine. And we'll leave those there. Okay. Where's command? Okay. Before I look at that too closely, this error is correct because this is supposed to produce an error. There's no 0 in the deck. So this will create a deck from 0 to 9, and then we print 1 plus the other, and then we append left a 6. Okay, pop left, take out the 6 and return that, and then we pop the 9, we get that. We append a 7 on the end. This should all still work because I didn't reverse anything. Clear, extend 1, 2, 3. Where were we? 9, 7, and then append left 8, and then pop left 8, and then pop the 7, and then we should have 6, 5, 4, 3, 1, 2, 3. Okay. Then we copy and print E, it's the same. And then how many 3s do we have? We have 2 of them, and a single 1, and no zeros. Index of 3 is 0, 1, 2, 3, 4, 5, 6. If we start over there, and index 0 doesn't exist. Okay, great. Now, I don't know whether it'll work, but we will see. So first we'll reverse it. We'll do that a bunch. E, copy E dot reverse, and then it should be different. I don't particularly know, but I'm doing stuff. Okay. Okay. 0 through 9. We reverse it. 9 to 0 and 9 to 0. 9 to 0, 9 to 0. Print D plus D. We append left 6. Good, it's on the left. And then we pop the 6 out of the left. That's good. And then we pop the 0 from there, from the right. Then we reverse it again. We should have 1 through 9 now. And then we have 1 through 9. And then we append 7. Then we append left 8. Then we pop left 8. Then we reverse it, and we should have 7, 9, 7, 5, 7, 9, 6, 5, 2, 1. And then we pop. Yeah. and then we clear it, and then we extend and extend, or extend and extend left. Print D. Extend 6543.123. Oh, is that wrong? I think that might be wrong. After the clear, huh? 6543.123. I think this is wrong. Reverse print E. Yeah. Maybe I didn't need to switch. Extend and extend left. 3, 1, and 0. Yes, the count should be the same. 6 of 3 is 0, 6. Okay, I think this is wrong. Let's remove a bunch of stuff. Make it easier. Shorter. Actually, let's make it empty. This should just give us... I don't really need these things anymore. I'm interested in this part. That should give us 6543.123. Wait, what did I exactly... Yes, that should have been 6543.123. Okay. So we should have 1, 2, 3, and then 3, 4, 5, 6. 6, 5, 4, 3, 1, 2, 3. So D should be 6, 5, 4, 3, 1, 2, 3. It is not. So maybe extend and extend left are not happy campers. What happens when I do this? Then it's correct. Oh, I think I know what happened, I hope. We switch append to append left. Oh, yeah, duh. Extend and extend left. Extend, all it does is call append. Extend left, all it does is call append left. And we already switched append and append left. So if we switch, if we have one thing and another thing, how should I visualize this? We have something pointing this way, something pointing this way. So if I switch one of them, pointing the other way, but then I switch the other one, and this is pointing back the other direction. Would you like to know what analogy I'm thinking of? There's a little part in an Asterix and Obelix book where this is a graphic novel, comic. It's comics basically, but like books of them. And this is a French comic about ancient France in the time of Julius Caesar. And there's a little village there that, you know, resist the invaders, etc. And they have fun, you know, stories. At one point, the chief of this village, who is important and thus has, you know, people carry him around. So there's two guys who hold a shield, and the chief stands on the shield. So at one point he's making some kind of... Is it the chief? No, it was a rival clan that had hired a Roman or something. I think it was another village. Anyway, dude is standing on a shield that's being carried, and he's, making a pronouncement, and then he wants to say that he turns his back on someone, and so he turns his back on them, and he's no longer facing them, and then his shield bearers also turn their backs on them, and then the guy on the shield ends up facing them again, and he's not pleased with the help. So that's what we were doing here. I already switched append and append left around, didn't need to do the other bit. So that's cool. Insert. Insert adds a new element at the desired index, and I think that may be a problem. Will it? Next. No, I don't think so. I can just take references. Or can I? See, if I'm relying on the next and previous, insert doesn't really have an analog of the reversed version. So if we're going forward, we have next. I will say I want to insert one. I will iterate through. If I say insert at index 2, some element, I will say, skip 0 and 1. And then I will say I want this thing at index 2. And so this one's next will point here, and this one's prior will point here. But if I have that backwards, 0, 1, 2, and then, will that be a problem? I think it will. Because then next and prior would be different. How will I do that? This is really cool, and I really want to make it work. Let's see. Because instead of having a next and a previous, I'll be going this way. Instead of having a next left and then the next right, having a prior. Yeah, that's bad. How will we solve this one? Maybe we can just check identities. That's an idea. There we go. I have got it. Eureka. I will check the two objects that I'm moving aside, and I will see is this object's next one this one, and is this object's prior one this one, or are they different? If they're different, then I don't want that. Instead of next and prior, I want prior and next to see what's what. And I'll be using identity checking with is. We don't do that very often. That'll be fun. Fun! We did identity checking to make a deck. It's fun. Okay. 4. Index value in zip. I need 2 things here. Index and element. And here I want to zip through the nodes. Range I and self dot underscore iter. Yeah, very handy. I want to go through those. Let's think of the basic idea for this algorithm. We're getting a number, which represents the index that we want this new element to be, and we're getting the element that we want to put in there. And if we get do I want to do this? Think. Do I want to do this kind of a zip, or do I want to set up an iterator and then go next a bunch? Do I want to do +1? No. Let's do some checks first. If not I, meaning I is 0, we're gonna save the first one. First, then we're going to say the new first one is a node from this element. Now we need to get the next or prior, don't know which. If temp.next, it's a temporary one, not a next one. Oh. No, let's set up this one as a node first. If, and then we see if first.next, so we set up a temporary node. If the first one has a next for it, then temp.next gets first.next, and first.next is temp. And self.first. This needs a bunch of self. Self. What in the world am I doing? already figured that part out. If I in, so that's, if not I is if I is 0. Now if I is, can I insert at an index equal to the length? Dot insert 0, 1, 2, 3. Okay. So instead, we can insert with an index larger than the length of the list, if we want. And I guess if the index is too negative, then it just puts it in the beginning. Okay. So, if not I, or what would be the smallest one? Negative 1, 2, 3, 4, 5, 6 over here. And now 7. I might as well show you what I'm messing with. So I have a deck, and I'm inserting at negative 7 the item 8. 0, negative 1, 2, negative 3, negative 4, negative 5, negative 6, negative 7. Okay. Okay. And the length was 7. Or I less than negative self dot quantity less than or equal to, I should say, oh, can't slice a deck, are you kidding? Oh, I see. Anyway, okay. If we use negative 2, insert at negative 2 something, then it is not in the beginning. It has to be the negative length, less than or equal to the negative length. Good. So if it's 0 or less than or equal to the inverse of the length, we will append left. If I greater than or equal to, how about, what if I do the max index? 0, 1, 2, 3. Okay. The max index? No. Max length? Yes. Greater than or equal to self.quantity. Append. Great. Now I am guaranteeing that I will go some amount. Okay. Maybe now I'll convert to a positive index. yeah, I should do that. If I is less than 0, oh, maybe we'll change that here. Negative. Oh, yeah, that's what we'll do. If I is less than 0, hang on. Okay, now I'm confusing myself. Let's see. What do I want to do? It's been over an hour. Should we stop here? I don't know. Not yet. I kind of want to do insert and remove. These might be larger things. The standard library collections.deque has some optimization. So if you, it knows whether you've chosen an element from the first half or the second half, and then it iterates from the beginning or the end, respectively. Let's see, because you can give a negative index if you want. Let's first take care of the extreme ends. Meaning something that's not actually a valid index. I equals the larger of this number and negative self-dot quantity. Yes. And the smaller of positive self-dot quantity and this. Let's do some testing of this idea. Okay, let's say x equals 10. And this will be our quantity, the length of our list, or deck, or whatever. And let's test some values now. How about 5? Still 5. How about 10? It is 10. How about 11? Still 10. How about a big old number? Still 10. Maybe 0? Good. 0 is fine. Negative 2, still negative 2. Negative 4. Negative 8. And 9. And negative 10, and that's as far as it should go. Awesome. Okay, that works. This ensures that it stays in a reasonable range. Now, if I is negative self.quantity 0, append left. If I in -1 or positive self.quantity, just append. Okay. Now what? Now if it's more toward the beginning, I want to iterate starting at the beginning and going forward. Otherwise, I want to start at the end and go backwards. If we let's convert it to a positive value. How do we do that? If I less than 0, I equals self.quantity minus I think. If our length is 10, and we give it, say, -1 for an I, that means we want it at the end. And 10 minus -1 is plus I. Yeah. Okay. That's good. -1 means the end, and then we have the quantity, that's index of 9. -10. We'd add 10 and get 0. That's correct. Okay. Very good. So now we always have a positive number. That's helpful. If I is less than self.quantity over 2, that means it's at the beginning, and we want our iterator to be self.iter. Else, let's make these, one of these, more than one of those, more than or equal to, no, in. It's one of these, we do that, it's one of those, we do that, and then we convert it. We'll never have both of these being true, so we technically don't need an elif. What if the quantity is 0? Oh, what if the quantity is 0? It'll be this one, and negative self.quantity is also 0, and self.quantity 0. Aha. If I didn't have this elif, we would insert something at 0, and it would go on both sides. We don't want that. Good. In Python, 0 and -0 are the same value. In some other languages, 0 and -0 are distinct values. If I is less than half the quantity, else iterator equals self dot reverse iterator. Okay. Ooh. If I have the beginning and the end, and I want to put something here, and then let's say I have 10 items, and I'm going to put something at 8, I will start from the end. I don't want to go 8 from the end. I want to go 10 minus 8. It's only 2. Else I equals absolute value of I minus self dot quantity. Okay. Good. Very nice. For index and value and zip range I. Equals self dot first. Yeah. Not last. Okay. What does reverse do exactly? Where is that? Reverse does not change first and last. Okay. Okay. Alright. This should, instead of guessing whether we need the first or last one, we already have the iterator, because this and the other one are switched whenever we need to. And so they will get the first or last one for us. We don't know which one it is. Self.iter, self.reveter. Do that and say current equals. Now it doesn't need to be conditional. Great. Current is the next iterator. Let's just do for index in range I. Is that doing what I wanted to do? Hang on. I have the first or last already out of the iterator. This is something we will definitely need to test, because off by 1 and backwards errors will abound, let me tell you. For index in range I, I minus 1. What if it's 0? It's not 0. There. Because after we've taken care of this, this is all there is. We're done. If it's negative, we make it positive. If we want to go the other direction, if it's in the beginning, we want to go forward. If we want to go in the other direction, we need the reverse one. And we need to not go as far. And so if we had, let's say, 1, we would get the first one. Does range 0 have anything? Can I do that? I'm guaranteed to have at least 1. So I get the next one from whatever iterator I have, and that's my current one. And if it was 1, that will get us something. I think I need to do I minus 1. Okay. So if we had 1, I will have range 0, which is empty, and that means our current one stays this one. And then I want to put it after that. And I know it's not at the very beginning or end. Do I? What if we have 1 item? It might. Yeah. No, if I have 1 item, I could have an index of 0, then we just append left. Or append. It's not at either end. So that means there's always an item before and after it at this point. Yes. Okay. So now we'll get oh. I think I need to do this because I want to get a node, and I want to get the next node or the prior node if we're going backwards. So, because in terms of what the deck knows, we have this one and the next one. It might not actually be node.next, but it's the one after. Now we need to check if it's prior and next or next and prior. Okay. Hang on. If we only change that one, then the current is actually just the first one. We want to keep track of 2. And that would be I'm going to do a multiple assignment somewhere over here. Equals n next iterator, and that would be current and n. So n will go into the current, and the next one of the thing will go into n. Okay. Alrighty. Let's make an empty node object. Can I have an empty node? Element equals none. I can. We have a node. We skip some. If current.next is n.next, this is using an identity check. That would need to be prior. If the current node's next one is n, and the n node's prior one is current, then those are next to each other. But if instead of we have current.next and n.prior, we have current.next going here and n.prior going over there, because we're looking at it backwards, then we want to do something else. If they point to each other, .next equals n.prior. Let's make current.next will be, do we make a node that we actually want somewhere? Temp equals node element. There. Current.next is temp. And .prior is also equal to temp. And then we will say the temp node has to change. Temp.prior is current, and temp.next equals n. Else I'm not sure how this will work for very short decks, but we will see. Current.prior equals n.next equals temp, and temp.next equals current, and temp.prior equals n. I have no idea, quite frankly, what's going to happen. So we'll do the usual things we do to test reverse, and then we will do d.insert 0 let's go with the letters here. B, C, C, D, E, F. Insert at 0 the number 1. want an empty one to work with. 0, let's add a 1. At the end, let's add a 2. Insert 7, 8, 9, -9, and 3, d dot insert -11 and 4. And at this point we have 11. Insert 11 and 5. Insert 13 and 6. And then we will print D. And now E is empty. E dot insert 0 and 1. E dot insert some large number and 2. I don't know. And then print E. I don't know what'll happen. I honestly don't. Let's actually reverse that again. E dot reverse. E dot insert 4, 3. Okay. I don't know. I really don't know what will happen. What would I want to happen? I would want FEDC ABC. Let's just run it. FEDC ABC. I print that. Copy and reverse it. Print that. Okay. At 0, I inserted a 1. Yeah. And then at -1, I insert a 2. Is it supposed to be right after? It's not supposed to be right after. It's supposed to be before. It was -1. It should have just appended it. FEDC ABC. And then we got a 2 at the end. That's wrong. Because -1 is supposed to be the end. Why did I do that? Why did I do that? This isn't a thing. Okay. This is actually wrong. -1 is not the last one. -1 means what was the last index is now this. And that moves something aside. Okay. But if it's the quantity, okay, let's try that again. I insert a, where's the 0? Oh, it's the index of 0. At 0, I insert a 1. And then at -1, I insert a 2. Where's the 2? There's no 2 here. There's 3, there's the 4, and the 5, and the 6, E I cleared. Should have a 1, and then a 2. I never printed this, did I? That would be good. If I have 1, 2, and I reverse it, I have 2, 1, and then I should have 2, 1, 3. 2, 1, 3, good. Where is the number 2? I don't know. Where's the number 2? I don't know where it went. 4, 3, 1, F, E, D, C, A, B, C, 5, 6. There shouldn't be, oh yeah, there should be 2 C's there. What if I had F, E, D, C, A, B, C. F, E, D, C, A, B, C. And then, okay. Dot insert 0, 1. Dot insert negative 1, 2. Copy, paste, copy, paste. Everything seemed fine except inserting at negative 1. Four, 3, 1, F, E, D, C, A, B. 2 should be in there instead of C, and then 5 and 6. Where did it go? Where'd it go? I don't know what happened to it. I thought it might be in the wrong place, but just gone is unexpected. By the way, there's a good chance that indexing and slicing will do a lot of this stuff. So I might just replace it with just get the index of something, move a lot of this into there, and then this will just like get element here and get element here +1 or -1. I'll change it to positive, etc. So I might be moving this somewhere else. But where did the 2 go? Let's add so we should get, in theory, blah blah blah, AB 1, 2.5, and then 2, and then C. They're both gone. They are not there. When we insert into the middle, which is the only reason to use insert, basically, because otherwise we have append and append left. It doesn't do that. Why doesn't it have those? Current.next is end.prior. Leave this. Otherwise, that. something somewhere is going wrong. And I think it's when we insert into the middle. Because everything else works fine. Okay. Dot insert at index 3 the number 5, and then print D again. There should be a 5 in there. It's not there. 0, 1, 2, 3. There should be a 5, and then C, A, B, C. And it isn't. That's bad. Let's do some print debugging. There's a node of the element. If current.next is n.prior, do that. Let's just print after. Print current and n and what exactly do I want to check? Let's start with this. Something stuck here? Something went funny there. I don't know what happened. Okay. Hope I didn't do something wrong. That's not the right one. Okay. There. Why is it... What's it doing? It's doing something wrong. Oh, this thing? For real? What the heck? I don't know why it's doing that. D.insert. What did I do wrong? This was only when I printed, wasn't it? Nope. Something's very wrong here. What am I doing? Okay. Something is bad. Around here somewhere. maybe it's after I insert something's wrong. Yeah, that's fine. Something weird happens when I insert and then print again. Not this one. Why? Why? Is it just... Oh, maybe it's a cyclic reference? Something in here? Current.next is n.prior. No, current.next will never be n.prior. Current would have to be n.prior, and current.next would have to be n. This is all wrong. Current.next is n. There we go. Yeah, that was wrong and bad. So that would never be true, and it was going to the else. And it was saying this one's prior one, and this one's next one, or this, and it was going around and doing nothing very good. So the next one is n. The next is temp. And temp.prior one is current, and the next one is n. Otherwise, the current's prior one is temp, and okay, that should be better, I hope. Yeah. Still not in there though. Why? That's odd. Print, I inserted it at 3. 0, 1, 2, 3. Let's see what the current element and temp.element and n.element. Let's see what they are. A, 5, and C. Is that right? I don't think so. I don't know what's going on here. This is supposed to be changed afterward. Let's say current.next.element and current.prior.element something. Datamorph says, I'm back just in time. I say yes, just in time to see me wondering why it is broken. What exactly am I doing wrong? If current.next is n, then current.next is now temp. Temp.prior is the current one. Temp.next is n, and n.prior should be temp. Yeah. And not next. Should be temp. That might work better. Now there's a 5 in there. It's in the wrong place. Let's do something longer. Okay, and we're inserting a 5 in there. Maybe it is correct. Is it only when it had the half thing wrong? If I inserted it 3, 0, 1, 2. This is only a 2. Should be 3. Let's take that out. Didn't I tell you there would be off by 1 in each direction issues? So if we inserted 3, ABC 5, okay. Dot insert 3, 5. ABC 5. ABC 5. Okay. That's correct. At least. Now, why did it seem to go onto this end? 1, 2, 3, boom. Maybe that was the halfway point optimization. ABCD should be ABC 5. Oh, it didn't like that. Didn't like that at all. Yeah. Oh, because I'm doing the print thing when maybe I shouldn't. This should be ABC 5D. ABCD. That's wrong. Does it do anything correctly? Not so far. How about at 0? 0 it can manage. How about -1? Should be just before the end. ABC 5D. Nope. Doesn't do that either. Something here is very incorrect. I would like to find it. But it's getting real big. And this is wrong. Still doesn't work. How about something in the middle there? Now it shows up. -1, -2, -3, so that's good. It works sometimes, but not all the time. Let's do the following. Okay. For I in range -10, +10, Deque, and insert it at the index and print. That'll be 20 things. That's fine. Show me. -1, 2, 3, 4, 5, 6, 7. So 10, 9, 8, and 7. 9, 8, and 7 worked. and then -6, and it failed. Should have been between A and B. So after A, which is not. After B, it is. After C, D, E, F. That broke G, so that's bad. Uh, 5 and G, or just, oh, then 5 is, oh, for 0, yeah. And then 1, this is very wrong. 2, 3, 4, 5, 6, 7, 8, 9. B, C, D, E, F, G, 5. Okay. Some of them are okay. Some of them are not okay. Some of them are okay, and some of them are not okay. That's not super helpful. Let's see. 10, 9, 8, 7, 6. -1, -2, -3, -4, -5, -6, -7. So -6 should be after the A. 10, 9, 8, 7, 6. This should have been A5, B, C, D, E, F, G. That's bad. Why did it put it there? I really don't know. That's a good question. This is what happens when you try to reverse an O of 1 operation. And when you want to accept negative indices for stuff. The itemorm asks, how's it coming along? I broke stuff. The insert method doesn't work. Just doesn't work. This AB5 none should have been A5 B, C, D, E, F, G. But it isn't. But this one, A5, AB5, but this one's correct. And this one, and this one, and this one. This one is broken. This is what we call an edge case. When it's broken at the edges, not a corner case, when you have just a weird situation. Like in a game, if you have this, wizard character with a barbarian sword and goblin shoes that he would never have usually, then it turns out something weird happens. That's a corner case. But when the number is large or close to 0 or close to this, then it's just that's just edge cases. Breaking things means you must be making progress in some direction. So when it's equal 4, 5, 6, 7, when it's equal to quantity minus 1, negative quantity minus 1. When it's negative quantity minus 1, because this is 1, 2, 3, 4, 5, 6, 7, and quantity minus 1 is 6, so when it's negative 6, negative 10, 9, 8, 7, 6. So negative quantity minus 1. I'm going to write that down. Negative quantity minus 1. This would be negative quantity plus 1. So it's broken there at negative 6, negative 5, 4, 3, 2, 1. At negative 1 is broken. 0, it works. 1 is broken. 1, 2, 3, 4, 5, 6. 6 is broken. Negative 1 and 6. Which is quantity minus 1. Why is it doing that? Now we find out. The Atom Arm asks, do you have a favorite distro of Linux? I don't. I've used Ubuntu before for a couple hours. Personally, I mean, I've used some distro for work. Maybe it was Red Hat or something for a little bit. But no, I don't use Linux really. So don't have a favorite. I've seen people use Arch Linux and say it's great because it's totally customizable and look how I can change even the fundamental parts. It's so cool. And then they spend, you know, the next day changing it back. And it's like, maybe that wasn't such a good idea. But anyway, this is broken near the edges. Should I special case them? No, that would be bad. Also, you can call me Adam if it's easier to say. I'll do that. Thanks, Adam. I've been going for over 2 hours because I want to fix this. I really do, but I think it might be broken. Maybe next time we should be fixing insert. I don't know. I feel like there's something obvious that I should just delete one character somewhere. Here's what I can do. If, for the broken ones, if I in 1 minus quantity, self.quantity, sorry, negative 1, 1, or self.quantity minus 1, print something. I don't know. Where do I want to print that? How about at the end? I'll print, this is only for the broken ones. Instead of printing what it looks like, I can already see that. Adam asks, would you ever consider doing a walkthrough tutorial using the official Python Beginner's Guide? I learn much better by listening and watching than reading. I don't know, because it's a big tutorial. That's an idea, though. Just go through the tutorial. Could be good. Could be fun. It's an idea. I'll think of that. Think about that. You already thought of it, and now I will consider it. But what should I print here? N? No. Node of some kind. None is the temporary element, the temporary node. N. Why do I have N in here? Because N never got the next one. N or none. No. It's only happening here, because sometimes current.next isn't N. So when N is none, or when N isn't a thing. If we don't go through this loop any times, then N is just an empty node. So current.next would not be N. So this would be N or none. No, because we have a node with none. It's cutting that off, and that's bad. Sometimes it works nicely, other times it doesn't work nicely. Let's print current temp and N. With I also to see the index that breaks. This is when current is none, and we have 5 for the temporary one, and N is B or F. But why is current none for those? Because I do current N equals N next editor, and sometimes it's none. Why is that happening? Current is a node with none. And where do I make a node with none? I make a node with none at N. Adam says, I'll give it a go. Thanks, man. Current has a node of none. assign n to current here and only do that once. Then it breaks. Wait, I is... It's always when it's 1? Oh, the distance from the end. Right. Because 6 is 1. If our quantity is 7, 1 minus self.quantity is -6, which is 1 away from 0. It's when we only go 1 and not 2. Let's do this. Oh, I have an idea. Okay. Then I will change this. Well, if current.prior is in, that might be the case. Might want to use first. That means it's the first one. That's what we want. Next or prior? I don't know. First dot next is n. First dot next. This is a repetitive thing. I don't want that. Let's get this written down first. Let's just get it written down and see if it works. I'm currently thinking whether I can take a shortcut. Okay, I think I can do that. Node equals current or first. Node, okay. Node So we save the first one, and then if we get 1 and it's not good, we will save it. Let's see. Let's see what this does. Let's see what this does. 5. Where'd it go? It's nowhere. 5, 5, 5. And then it's nowhere. Let's give ourselves an index value. Negative 10, 9, 8, 7. 6, it's nowhere. 5. 6, it should be right here. 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's still doing that. It's doing something. But now it's just not showing up. That's bad. It keeps being none. Oh, current. I didn't change it to... Okay. Now I'm pretty sure this will work. If you don't change the thing, it doesn't happen. 10, 9, 8, 7. Where is it? It's still not there. What? Say again. None. 5. It says none. Let me print node. That might be helpful. It's none. Why? I don't know. I thought I had it, but maybe not. Node is still being none. Holding something with none, which is the empty one that I made over here. Oh, for when it's n. Instead of node. If node.next is n, it won't be. N equals node. And it's always when I is 1. Because it's 1 distance away. Let's move this here to only happen in that block. Which one is it? Not that one. Or that one. This is the else. It's the else. So neither the next nor the prior is a match. Why? Why is that the case? the node's next one isn't n, the node's prior one isn't n. That seems impossible. Oh, it's when we don't move anywhere. Let's actually switch that around. Oh, what happens now? Not there in any of them. That's extra bad. No. This is not what I meant. I want it to happen at least once. If not, n is always something. If n dot next is n dot prior, that means it's our old one. N equals next iterator. Now what happens? 5, nowhere in there. Should be between A and B, but now it's not. How very frustrating. So those aren't happening. Getting annoying. Adam asks whether I've ever played around with malware or made your own. No. I once had the idea that if you made a batch file, like program.bat, and inside it, the only command you had was program.bat, and then you ran it, it would open, and then it would run program.bat, which would run program.bat, and then you get a bunch of little windows. And then you'd have fun trying to stop it. I don't know how you would stop it. But that's as far as it goes. And I never tried it, because I don't know how I would stop it. It's kind of the big problem, testing them. Have to set up a sandbox or something, and I bet it's a real hassle. Like more than this thing that I'm doing right now. And next. No. Is. And not prior. Let's see if that fixes it. Nope. It's just not there. A, B, C, D, E, F, G. With no 5 in between the A and B. Adam says virtual machine, probably. Virtual machine or a sandbox, something. I don't know. And there should be a 5 right there. And there isn't. 0, 1, and over there. And over there. When it only has 1, for index in range I, so when I is 1, we do this once. Current n equals n and next. So current gets the empty node. Oh. It's still always current. That's gotta be wrong. Next is current.prior. This can never happen. It would be circular. I guess you could make a circular queue. Is none. Node equals first. Else node equals current. Because current or first node, current was an empty node, which is truthy because it has no bool, so it would always be truthy. That was wrong. What else do I have over here? First is the next one, n equals an empty node. Put the empty node into current, the next one into n. Don't really need this, do I? Let's try this, see what happens. It's wrong, isn't it? It's printing the thing. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Something's wrong. For -1. Oh no, it's just printing. It's just printing it. Silly, silly me. So I don't need to print that. I have -6, 5, 4, 3, 2, 1, and 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Great. Fantastic. Let's see if there's anything I can take out in my flailing to fix it. Maybe I don't need this. I didn't need this, indeed. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I didn't need that. Good. I get the first one, I make a node, I iterate a bit, I make a temporary node, if current is the empty node, because you'll never have a node with, or will you? What if it's 1? Then the next and prior would both be none. That's wrong. Because this, let's see what happens if I have something with just one element. Deque d equals dq, it's empty. 0. Insert also 0, a 1. D. This might not work. It worked. Maybe it's because it doesn't matter. Because then first current, does it matter which? This seems like it shouldn't have worked. Or something. 0, 1, and 2. Okay. So it does work. Why does that work and not explode? Not actually broken anymore, huh? If current.next is current.prior is none, if there's nothing on either side, then node is first. Oh, we won't have one that doesn't point anywhere because we already took care of that. What if we have a large number that doesn't apply to that? Then is it broken? It is not. When I think it'll work, it goes kablooey. When I think it'll go kablooey, it works. I'm not sure why. No, these are, these I changes to something new instead of being out of the range. It is never outside, so if there only is a 0, then it's 0. When self.quantity is 0, I is always 0, and so that'll be that. When self.quantity is 1, we have negative 1 to something. This should give us 0, then 1, 0, and then 1, 2, 0. It does. I don't know why that works. But it works. Isn't that fun? I don't know why this works, but it does. That's something you never ever want to see in someone else's code that you're trying to work on. I don't know why this works, So if you want to change something, you will not know what's safe to change and what isn't, because we have no idea. It's bad. Node might be first, so this is if we want to go with the first one. We're just going with the first one or a subsequent one. I think that should just be fine. Because if I take this out, we have a bad day, right? I have to set it to something, don't I? It's got to be something. 555. Yeah, it's got to be something. I think that's first current. If node.next is n, then the next one gets the temp one, the prior one gets the node. We change node.next. Node is the temp one we made. And the temp one's prior one is the node, and the temp's the next one is n, and the prior one is temp. Okay. Alright. I think that's basically all we can really do for now, maybe. Adam asks, have you ever used a Raspberry Pi for any of your projects? I have not. I thought about it several times, every few months, thinking, oh, it'd be cool to get a cheap little computer that I can just, you know, plug into HDMI or something. But then you look at the Pi, it doesn't come with the case, then you get the case, then you get the power supply, then you have to load software on it, and maybe another SD card or something. I don't remember if it comes with wireless, I don't think it does. And you just have to add all these accessories to make it barely functional, well, it functions, to make it usable at all. And the price kinda went up when you add all those things, like a lot, like 50%, from $100 or whatever to $150 or $180 or something. I'm like, oh, it doesn't seem worth it. And of course, then I would end up with a Linux machine, which I don't really know how to use, and which requires making a lot of your own stuff and compiling just basic utilities, like I want to watch videos or whatever. It's a basic task, but it's not easy with the Raspberry Pi. So I ended up buying a mini PC that's it's kind of like a tablet, only it's a little thicker, and it doesn't have a battery. And it has lots of plugs for USB, Ethernet, power, HDMI. So somewhere between a tablet and a PC. It's like a tablet in that it has a screen, unlike a tablet in that it doesn't have a battery, it needs to be plugged in. It's like a PC in that it has all the plugs you'd want, etc. Unlike a PC in that it's really small and fanless and has a screen. So it's a kind of standalone-ish thing. Usable as a computer, but it's just really small, and you don't need a keyboard and mouse if you don't want. It is a lot better to have one, but you can just tap on the screen and stuff. And it's it runs Windows and can dual boot Android if you want. So I know how Windows works, so I can use that. It kind of struggles with HEVC video, H.265, which is very CPU reliant, and it doesn't have a great CPU. And I don't think it has hardware decoding for that either. But it's okay. Like when there's a lot of movement and like snow or something, then it has a tough time. But my main computer has a tough time with that too. So Adam says the Pi comes with wireless now. I already got something else, a little mobile machine for running stuff, and I can install whatever version of Python I want and run that. I can run League of Legends natively. not very well. It gets like 15-ish FPS. I wouldn't want to play it, but I can like spectate or something. It does YouTube, etc. And just Windows, which I'm used to. So, Pi seemed cool, but I got a different mini PC and one that included a screen. So, kind of sad that LOL no longer has featured matches in the client. It used to have a little UI element where you could look at various matches being played right at that moment by high-level players. And then they changed something with the queuing system, I don't know, and it was gone. And they never brought it back. So you can no longer, you know how in Dota 2 you can open the client and go to like the spectate tab and there's a whole pile of stuff? I don't know if it's called spectate, but you can watch Dota matches from wherever, and there's tons of stuff. It's like, it's very prominent. In LoL there was a little thing in the corner and it's gone. If you want to watch LoL stuff, you have to basically either spectate your friends or watch videos online. And you can't really click on champions and mouse over stuff for information because it's a video, right? So I got it for spectating, and then they took out spectator mode, which was kind of lame. But anyway, this works now. And there's a bug. Not anymore, there's not. Ew. I never think these things through, really. I'm gonna squish them, but I don't remember. Squishing the bug means I'm gonna have a bug on me. Yuck. Rather that than the bug. Anyway. Adam asked, which one did you get? I got a Pippo X9, P-I-P-O X9. Now there's like an X10, 11, and 12, something, whole bunch of different models. And there are a lot to choose from. But this was the only one I found that was somewhere between a PC, laptop, netbook, and a tablet. There were a whole bunch of tablets that run generally Android or maybe Windows, I don't know, I don't think so. And there were a whole bunch of mini PCs that were just the box, no screen. And this one was Windows with a screen. Basically a laptop that doesn't fold, and the screen is the keyboard. It's between, it's a weird thing, but it works okay. So, and this thing, we really didn't get as much done as I thought we would, and part of it took like 2 hours. This thing, this insert dealy, and like I said, I might be moving a lot of this logic elsewhere because I plan to make this sliceable. The collections.deque is not sliceable, so if I can do this, we will have, you know, one up on that. Isn't that neat? Okay, so today we changed the iterators a bit for iter and reversed and reverse, all those things. And insert. And it took a long time. I'm not going to put on that in the commit message, but it did take a long time. So I will be ending the stream now because I didn't intend to stream for 3 hours. I thought maybe half an hour, and then I'd have this taken care of. But this was really something. But at least I got to do this, huh? 0 of 1. That's pretty good. Anyway, that is the stream for today. Thank you all for watching. Remember, you can watch my other videos just on my channel. Click on the videos and they're all archived. I am tired. Like, comment, subscribe. I hope the sound wasn't too bad with figuring out where to put the headset boom mic. I want it far enough away to not be impacted by scratching and breathing, but close enough to be loud enough. So, thank you again. Next stream will probably be more of this stuff and things. And I think there's a remove at some point that I was planning on. Yeah, insert, remove, and rotate. So remove is very similar to insert, except instead of, you know, adding something, I'm going to take it out. I might also move a lot of the stuff to indexing things and just index stuff instead of finding and going through, etc. It's just going to be, you know, item or self dot, not self dot, self I is, you know, temp equals self dot I, and that sort of thing. I don't know. Anyway, that is the stream once again. And Adam says it was nice to meet you. I look forward to watching you stream again. I will stream again. I will return. But not today. Today I'm tired. And next time, more Python stuff. We'll see. Thanks again for watching. And have a good one.